Okay. All right, geometry, lesson 33, converse of the Pythagorean theorem. So we should already know what the Pythagorean theorem is. A squared plus b squared equals c squared, right? Okay, so basically that tells me if a triangle is a right triangle, then a squared plus b squared equals c squared. The converse of the Pythagorean theorem is if a squared plus b squared equals c squared, then I know it's a right triangle. Let's talk a little bit about c squared, or c, in this situation. What does c represent? Because that's really the most important part of the right triangle, right? What is c? The hypotenuse. How do I locate it? Opposite the right angle. Now, if I'm trying to prove it's a right triangle, right, I have the three sides and I'm trying to prove it's a right triangle, I'm not guaranteed on a right angle because I'm trying to prove that part of it, right? So if they give me three measures of a triangle, which one of them am I assuming would be the hypotenuse? The longest side, all right? The one with the largest number. So that should get us through quite a bit of what you're reading there. So the sum of the squares of the lengths of the two shortest sides is equal to the square of the length of its longest side, which is really weird, wordy way to say that. As an equation, we know what that is. Each of the shorter sides is called a leg. So just so that you're used to that terminology, whenever you see it, it says one leg of a triangle is this, another leg of a triangle is this, right? We're talking about the sides that are not possible hypotenuses or hypotenusi, or however you want to put it. Okay. All right, moving on. The converse of the Pythagorean theorem is true and can be used to determine whether or not that triangle is a right triangle. So basically they're saying if these things equal that, then we know it's a right triangle. Okay. All right, the Pythagorean theorem can also be used to determine if a triangle is acute or obtuse by using inequalities. This is called the Pythagorean inequality theorem. And I think that we've maybe have talked about this, maybe not. No? Okay. So this is how we want to look at this. And you see this down here. I'm going to rewrite it up here. So we got a squared plus b squared. And we're looking at the relationship to c squared, because what you want to remember is that everything is built around the hypotenuse. The hypotenuse is the most important part. So if it's equal, we say that this triangle is right. Does that make sense? Okay. Now, let's say we have a different situation where I've added up a squared and b squared, and c squared is bigger than the sum of a squared plus b squared. Okay? Because the hypotenuse is big, it is obtuse. Okay? Don't look at it as, this over here is small, because if I think about the left-hand side being small, I'll think acute, right? Because acute is less than 90. You want to think about this in terms of the hypotenuse alone. Okay, does that help? Okay? And if I have, obviously, if I understand that, and I have a squared plus b squared, where the c squared is smaller, the sum of the, or the square of the hypotenuse side, or possible hypotenuse side, is smaller than the sum of the two legs squared, right? It is acute, okay? Everything is built around the hypotenuse. So if the hypotenuse side is small, it's acute. If the hypotenuse side is big, it's obtuse. If it's equal, it's right. Does that make sense? Can we remember that? Okay. That should help you out. Now, I know you can't see this on the video, but the way that I illustrate this is that if I put my wrists together, right, and I put my palms basically perpendicular to each other, we can see that if there was an invisible line drawn between my fingertips, right, that would be a right triangle. Does that make sense? Okay? Now, if the hypotenuse is bigger than the square of the sum of my palm legs, it's going to push my fingertips apart. What does that do to the angle where my wrists meet? It makes it obtuse, right? Okay? But let's bring this back in, and if my hypotenuse is too small in order to connect the invisible line between my fingertips, it's bringing it in. All right, so what does that do to the angle where my wrists meet? Makes it acute. So do we see visually how the length of the hypotenuse can affect the shape of the triangle? Okay, good. All right, lesson 34, properties of parallelograms. There are effectively 4 properties of parallelograms that you want to know. These 4 things are true. You want to know them. In terms of parallelograms, we're talking about squares, rhombuses, and rectangles. These are all types of parallelograms. All of them share some basic properties of parallelograms. They'll all share these 4 properties. All right. 1. Okay, 1. If a quadrilateral is a parallelogram, then the opposite angles are congruent. Okay? So if we can remember this, and I've tried to put the important parts in bold because everything else is going to be written pretty much the same way, right? If a quadrilateral is a parallelogram, then something. So I want you to remember the bolded portion of this. Opposite angles are congruent. If I have a parallelogram, so once they tell me this such and such a figure is a parallelogram, then I know all 4 of these things to be true. Number 1 is that the opposite angles are congruent. Okay? Can we remember that? So get a picture here. Angle J is congruent to angle L. Angle K is congruent to angle M. Right? Once I know what one of those angles is, right, I know the opposite angle is the same thing. Okay? The second thing I know is that if a quadrilateral is a parallelogram, then its consecutive angles are supplementary. So basically we're saying J and M are consecutive. Basically think about it this way. We know what opposite angles are, right? Those are angles that are diagonal from each other. We tend to forget what angles are consecutive. Let me keep it easy for you. If they're not opposite, they're consecutive. Right? Because there's only so many angle options in a 4-angle shape, correct? So, what angles are consecutive to angle J? No, what angles are consecutive to angle J? We're just talking about angles. Angle what? What is consecutive to angle J? Well, let me ask you this question. What angle is opposite to angle J? L. Okay, easy. J and L are opposite. So if it's not opposite, it is consecutive, right? Is angle K opposite to angle J? Huh? No. So it is therefore consecutive. These are consecutive. What else is consecutive to angle J? Angle M. So in a quadrilateral, an angle will have 2 consecutive angles to it. Okay? Now, here's what we know is that we knew once it was a parallelogram, we knew M and K were equal to each other, right? So it doesn't matter, right? Those things are equal to each other. What we're saying is that J plus K is 180 degrees. Okay? But because M is equal to K, does it matter if I say J and K are equal to 180 or J and M are equal to 180? Doesn't matter because I know M and K are equal to each other. You see what I'm saying? Okay? Just as some practice here then, what angles are consecutive to angle K? J and L are consecutive. So L plus K is 180. But so K plus J is 180. Because J and L are equal to each other, it doesn't matter. Okay, you follow me yet? Okay, I want to make sure that you get your heads wrapped around this because it's easy for me to say, but just because I'm saying it and you're seeing it doesn't mean that you understand it. Okay, and you need to understand it so that we can pass our tests, right? So we can get a good grade in the class, right? So we can move on and not have to take another math class, right? You say, I'm never going to need this again. Fine. If you never need this in your life, fine, but you know what? You need it right now because right now you need to pass the class, right? Okay. All right, if a quadrilateral is a parallelogram, then its opposite sides are congruent. Congruent means they're equal to each other. So JM is equal to KL. Okay, once I know that I've got a four-sided figure that is a parallelogram, the opposite sides are congruent. Okay, so if they told me that JM was 9, what would I know about KL? It's 9. If they told me that JK was 10, what would I know about ML? It's 10. Okay, so that's rule number 3. Rule number 4 is that the diagonals of a parallelogram bisect each other. What does the term bisect mean? Split into two congruent halves. Yes. So if I know that this is a parallelogram and I know JE is 7, what do I know about LE? 7. All right? That doesn't mean that MK is equal to JL, does it? No. Okay? But if I know that ME is 15, what do I know about EK? It's 15. Okay, is that, I'm not trying to lower this down and ask you questions that are like, no, duh things. I just want to make sure that we understand this. So, let's go back through this. All right? We know that opposite angles are what? Opposite angles are what? If a quadrilateral is a parallelogram, then opposite angles are, come on, let's use mathematical terminology, congruent. Okay? So opposite angles are congruent. What are consecutive angles? Supplementary. What does the term supplementary mean? They add up to 180. Okay? If they're not opposite, they are consecutive. Okay? We can identify opposite. We need to work on consecutive. Okay? So we know that the opposite angles are congruent. We know that consecutive angles are supplementary. What do we know about opposite sides? Opposite sides of a parallelogram are congruent, and diagonals do what? Okay? All right, diagonals bisect each other. All right. All right, that's the end of those notes. All right, let's see if we can get into some of this here. All right. All right, the diagram shows, and this part of this, I don't even know why they include it because it's not important, but what they do tell me is that this shape here is a parallelogram. That's the important part. Okay? We're looking at number 1? Okay. Yeah, so it shows the parallelogram shaped component that attaches a car's rear view mirror to the car. That's not really important is what shape it is or anything like that. Okay, what's important is that this is a parallelogram because that means that I know 4 things about it, right? Okay, so the first thing that I want to do is do what with the information that they've given me? Put it where it needs to go. So I'm looking for UR. UR is down here, right? I'm going to go ahead and write 25 there. RX is 16. And STU, that's this whole angle right here, is 42.4 degrees. They want to know what is ST. What is ST? What is ST right there? Katie, what is the length of ST? That's this line. 25, right? Because what? How do you know that? Because it's a parallelogram, and what do we know about parallelograms? Be more specific. What you learned 4 rules. Can you tell me which rule tells you that ST is going to be 25? Is it opposite angles are congruent? Well, I mean, ST, is that an angle? No, it's a side. Okay, so we're looking for a rule that involves sides, right? Opposite sides are congruent. Good. Okay. ST is 25 because the side opposite of it is RU, and they told me that this was a parallelogram, right? All right, Jose, we want to know what XT is. That is this length right here. What is XT going to be? 16. Can you tell me what rule tells you that's going to be 16? Diagonals bisect each other. And RT is a diagonal, and RX is half that segment, right? So the other side's got to be equal to it, okay? If they had told me RX is 16 and they said, what is RT? Do we know what we would get there? Could we find RT based upon that? What is RT? 32, right? Okay, 32. All right, let's look at RST. RST. Okay, is that right? Is that down here or here? Is it top left, or bottom right? Top left. So we want to know what this angle is right here. All right, Michael, how would you go about finding that?
Well, isn't it,
So we have two rules that deal with angles, right? They're consecutive angles. Great. Okay, what do we know about the consecutive angles of a parallelogram? They're supplementary. Okay, supplementary means that they do what? They add up to 180. So what math am I going to do here? 180 minus 42.4. Okay, so, I'd get 9 there, 10 there, 9 there, 10 here. 6. Did I mess something up? Oh, gosh, that should be a 7, right? Okay, 7. So what, 137.6? Okay, 137.6. All right, so we're looking for ST is 25, RST is 137.6, and XT is 16. Don't see anything that matches that. Looks like C, right? And that used 3 of the rules, right, that we have. The only thing it didn't use was the opposite angles are congruent, correct? Okay, but knowing all 4 of those is really important. Okay, let me see if I can scroll down here. We don't have a lot of time left. It's 8:40. Well, we got about 10 minutes before I stop. I want to get into something that deals with that's with some of our triangles. Let's look at this question. This should be 6. Find the value of x in the triangle below. That one should be really, really easy, right? What am I going to do there? Pythagorean theorem. So 2 squared equals x squared, right? So 2 squared is 4. 20 equals x squared. What do I want to do with 20? Square root it, right? So yeah, we can get 2 and 10. We can get 2 and 5. So the simplified radical form of this is, okay, is there anybody in here who's unfamiliar with how to simplify a radical? Have we talked about this? Jose, are you familiar with this? Okay, so all we do to simplify a radical is we do the prime factorization of this. Are you familiar with how to do prime factorization? So because it's a square root, right? Square root of 20, we don't often write that 2 up front, but we get that. So that means that I'm looking for 2 of a number, okay? And because I had 2 2's, whenever I take it out, it just becomes 1 2, okay? What is left, right, what I don't have pairs of, goes back underneath the radical. Does that make sense? Okay, Marcos, does that make sense? Okay, so we get 2 radical 5 equals x. And then we could go in and test our answer by saying 2 squared plus 4 squared equals 2 radical 5 squared to see if those things come out that way, okay? All right. All right, do we want to see a 33 question or a 34 question? Here we've got one. We want to determine whether or not the triangle below is a right triangle. How do I set this up, Katie? 13 squared plus 14 squared equals, okay, well, let's do this. Let's go ahead and leave that equal sign off, because if it's not right, I want you to be able to tell me if it's acute or obtuse, okay? 13 squared, what is that? I think it's like 169. 169. I don't remember my 14 squareds. 196. 196. 361. So we want to take 169 and 196. 365. Okay. All right. So what is the relationship between 365 and 361? How would I'm going to have to write an inequality, right? Because it's not equal to. So which way does the arrow face? What does it point towards? Points towards 361 like that, right? So is this acute or obtuse? Because we know it's not right. All right, which number represents the hypotenuse side? 361. All right. Is my hypotenuse big or small? Small, so my triangle is acute. That's right. Okay, now you'll see that it's not super small, and that's why it looks like a right triangle, but it's off by just a little bit, right? But even off by just a little bit keeps it from being a right triangle. Does that make sense? Okay. All right. Let's see. We can do that same thing here, even without the visual, right? You would do, how would you set that up? 7 squared plus 14 squared equals 20 squared, right? And we wouldn't necessarily say equal. We're going to leave that part of it blank, right, until we see what those numbers come out to. At this point, though, we feel like we have a pretty good understanding. I feel like question number 1 did a pretty good job of getting you through a lot of the different rules and possibilities. Okay, but you need to remember those 4 rules. They need to be someplace where you can remember them, not just notes that I've given you, but you need to make sure that those things are clear. Even if you just write down the bolded portion so that you know, all right, parallelogram, opposite angles are congruent, consecutive angles are supplementary, opposite sides are congruent, diagonals bisect. If I know those 4 things, I can solve a lot of these types of questions. Yeah, Michael? Yeah, I'll do number 11. Good. Glad you asked. What are the measure angles of TQR, QRS, and SRU? So, all right, so it wants to know this angle, right, TQR, QRS, this angle right here, and this angle right here. Okay, well, I know QRS, that's the easy one, right? It's 82 degrees. All right, angle TQR, what is the relationship of TQR to angle T? They're consecutive, and that means that they're supplementary, right? So I'm going to do 180 minus 82, right? Got 7, got 8, right? So I get what, 98 degrees? Does that make sense? So I got 98 degrees. Now, this outside angle, what you want to remember is that what are these 2 angles? Right? They're supplementary pair, right? Or a linear pair. But here's a thing that I don't know if this is covered in your book, but if you should be able to tell by looking at it that if these 2 angles are supplementary and these 2 angles are supplementary, then angle Q and this outside angle are going to be the same. Now, here's the other thing that you can look at this for, is that what do we call this shape? It's a parallelogram, right? Which means these two lines are parallel, correct? Which makes this line right here a what? No. Think about two parallel lines cut by a transversal. Well, if I go back to lesson 12, I learned 4 different things about two parallel lines cut by a transversal. What would we call those two angles? No. Corresponding angles. What do I know about corresponding angles? They're congruent. So what I learned about angle SRU is that it's going to be equal to angle TQR every time. So it's 98 degrees. Does that help? It might be easier to see that it's a supplementary pair with angle QRS, but just so that you're also seeing that we can still use some of the things we learned from lesson 12 when we're talking about parallelograms. Okay? Does that make sense? Jose, Mark, Marcos, Katie? Okay. Any other questions for this lesson that you want to look at? Take a quick look through there on anything that we didn't cover. Going once, going twice. All right, I'm going to stop the video there and let you guys work.